let's go ahead and take a look at some different things with the derivatives. First, we're going to start off with the function f of x. We know that its derivative, f prime of x, comes from the difference quotient, the limit as h approaches 0, of f of x plus h minus f of x divided by h. And we knew that that comes from just working with the slope, and we're finding an instantaneous slope, instantaneous rate of change. Let's make a little change to this. Do a new function. Let's say we have a function m of x, and let's call that a combination of f of x and plus g of x. Now, if we want to take the derivative of m of x, m prime of x, that will be equal to the limit as h approaches 0 of m of x plus h minus m of x divided by h. Now, using some substitution, that's the limit as h approaches 0. m of x plus h, we're going to rewrite it in terms of f and g. So that means I'm going to have f of x plus h plus g of x plus h minus m of x. Well, m of x is equal to f of x plus g of x, all divided by h. And now it's just a matter of doing a little manipulation. I'm going to go ahead and distribute the negative here into the quantity behind it and do a little bit of a rearranging. So our m prime is going to now be the limit as h approaches 0 of f of x plus h minus f of x plus g of x plus h minus g of x, all divided by h. And that should be okay when I distribute that negative inside this quantity here. Both of those terms are negative, and by the commutative property of addition, I can go ahead and move some of those terms around, and sure enough, we'll be at this expression here. Well, now we can do another little property, and it's a distribution property, although usually when we talk about distribution, we're going to talk multiplication. This time, it is certainly okay for us to talk about as a division. So I could take f of x plus h minus f of x divided by h plus g of x plus h minus g of x divided by h. And if you're not sure about that, think about it. You've got two fractions with a common denominator. And if I have a common denominator and I'm adding them, we can combine them together, and sure enough, we end up with that step right above it. One last thing then now. With this limit as h approaches 0, in one of the other little screencasts, we said, you know what, we're going to go ahead and take this limit, and let's take the limit of each quantity inside. So let's take the limit as h approaches 0 of f of x plus h minus f of x divided by h, plus the limit as h approaches 0 of g of x plus h minus g of x divided by h. Now, really, if we really wanted to, we could take that limit as h approaches 0 of each and every one of those pieces inside those quantities. But it's kind of convenient right now to look at where we're at. If we take this just one more step, this limit as h approaches 0 of f of x plus h minus f of x divided by h, we all know what that looks like. That's f prime of x. Plus the limit as h approaches 0 of g of x plus h minus g of x divided by h. Well, that's going to be g prime of x. And so our derivative, the derivative of a sum, is equal to the sum of its derivatives. We can take the derivative of each part. Really nice. Now, you ended up working a problem in this last homework assignment that was called a habit of mind problem. And it had you looking at what happens if you've got a product. And in that habit of mind, it started off with you thinking, well, what if and taking an example, what if I find two different functions, I derive them, I take the product, and then do the derivative, or what if I do the derivatives first and then take their product? Came out not to be the same thing. So we're going to go ahead and look at how do we derive a product. And the steps that it walked you through the steps that it walked you through just talk about the manipulation that you would need. So back to the original, m of x plus h minus m of x divided by h. With a substitution, we'll have f of x plus h times g of x plus h minus f of x times g of x divided by h. Now I did forget one little thing, so allow me to take these, let's slide this over just a touch. I did forget to go ahead and make that the limit as h approaches 0. I have not taken the limit yet, so I need to keep that there. Now one of the things that's awfully nice in mathematics, but very kind of sneaky, is that we can do some equivalent statements. And it might not be entirely obvious of what to do, and this is part of what that problem was in the homework set, is it said prove this identity. Well, really what it was coming from was, we're going to take this expression f of x plus h times g of x plus h. I'm going to make a little room for myself and make that f of x times g of x all divided by h. And what I'm going to do here is I'm going to put into the problem something that's not going to change the problem. In particular, I'm going to go ahead and put in a minus f of x times g of x plus h. And it looks like I need to give myself just a little more room, so I'll take this, we'll slide it over just a touch, and we'll put in a positive f of x times g of x plus h. Now notice when I put in those two terms, I really haven't put in anything. I've added in 0. I've got a negative term, I've got a positive term, I've added in nothing. Now what it allows us to do is we could take this and just with that little manipulation, we could do some rearranging. So I get the limit as h approaches 0 of f of x plus h times g of x plus h. Actually, let me take that back. Let's take a look at this here, and because of all my terms and things are looking good, let's go ahead and factor, because in those two quantities in that first group, both of those terms have that g of x plus h. So if we pull out a g of x plus h, so I got f of x plus h minus f of x times g of x plus h plus, and in the second group we're going to pull out the f of x, so I'll have g of x plus h minus g of x times f of x all divided by h. And now we're going to do something like we did on that previous problem. I can come up with a distribution. I'm going to distribute this h, but I'm going to be kind of sneaky how I do this. As long as I let it go to each one of these quantities, we're good. And so if I say f of x plus h minus f of x divided by h times g of x plus h, we should all be okay with that, plus g of x plus h minus g of x divided by h times f of x. And we're still taking the limit of, now because I've got those two quantities, I'm going to go ahead and make it the whole group there. So we got the limit as h approaches 0 of all of that stuff. Well, hopefully you can see what we're going for here. I could take that limit of the quantity, we could say the limit as h approaches 0 of f of x plus h minus f of x divided by h times g of x plus h minus the limit as h approaches 0 of g of x plus h minus g of x divided by h times f of x. And now let's go ahead and evaluate the limits. When we look at these limits, we see that this part here, that should be very familiar for us. That's our f prime of x. Now in this second group, we do have to worry about that h. It is inside the limit. As an h approaches 0, x plus h is going to be g of x. Oh, I messed up on a sign here. let me go back up here. This addition, this should be an addition right here, which means that this should be an addition right here. Sorry about that. So now plus, let's take the limit of, let's see, this limit here. Oh, we know exactly what that looks like as well. That is our g prime of x. That's our derivative of g. Now, the f of x, as h approaches 0, there is no h, and so we're just left with f of x. And so the derivative of a product comes out to be this setup. We call this the product rule.